So finally, to make things as meta as possible, meta-reasoning has actually been a motivating pedagogical goal for the design of this very course. You'll notice that for almost every lesson, we've started with an example of a problem that you could solve. In incremental concept learning, for example, we started by giving you several examples of foos and not foos, and then we asked you, is this a foo? In production systems, we gave you some information about a baseball game and asked you to decide what the pitcher should do next. In learning by recording cases, we gave you a world of rectangles and asked you to decide what color a new rectangle might be. In classification, we gave you a bunch of pictures and asked you to decide which of those pictures were birds. In planning, we gave you our blocks microworld and asked you to develop a plan to go from our initial state to our goal state. In each of these, we've started with a problem that we could solve that we then wanted to design an agent to solve. These examples then motivated our discussion not necessarily of how we did it, but how we could design an agent to do it. Then at the end of each lesson, we revisited that example. We took the reasoning method that we designed for our agent and looked at how that exact reasoning method would allow it to answer the same example with which we started the lesson. When you did the example at the start of the lesson, you didn't necessarily know how you were able to solve that problem. You could speculate, but you never know for sure. But then by building an agent that can solve that problem, we start to gain some understanding for the processes that we must be able to engage in order to solve that problem as well. So by designing the agent, we develop a greater understanding of our own cognition. So in this way, the very design of the lessons in this course has been driven by trying to develop metacognition in you. In fact, developing metacognition in students is the entire goal of my own PhD dissertation.